All right, let's talk about one of the biggest challenges in AI today. You've got these incredible, massive models, but how in the world do you customize them for your business without completely blowing your budget? Well, that's exactly what we're going to break down.
So the old way of doing this, what we call full fine-tuning, is just brutal. Seriously, imagine you have a 70 billion parameter model, and just to teach it one new thing, you have to retrain the entire thing. It is incredibly slow, it is wildly expensive, and you know what? You could actually end up making the model worse by messing up its original knowledge. For most teams, it's just a non-starter.
Thankfully, there's a much more elegant solution. It's called PEFT, which stands for Parameter Efficient Fine-Tuning. And the idea behind it is so simple, but it's totally revolutionary. Instead of changing the whole model, you just freeze it. You don't touch the core knowledge at all. You only train a tiny little fraction of new parameters that you add right on top.
Here's the best way to think about it. Imagine that giant base model is like a complete encyclopedia. It's a finished, unchangeable source of truth. Now, a super popular PEFT method called LoRA, that's like a little post-it note you stick on a page. The note just says, hey, for this one specific thing, ignore what's printed here and read my note instead. See? You're not rewriting the whole book, you're just adding a tiny, super targeted instruction.
Okay, for all you architects and engineers watching, here's another way to look at it that might hit closer to home. That big frozen base model, that's your high-performance engine. It's doing all the heavy lifting. Trying to do a full fine-tune would be like tearing down and rebuilding that entire engine block. But with LoRA, we're not doing that. We're just bolting on a tiny tunable carburetor. We make small, precise adjustments to how the engine performs without ever touching the core machinery itself.
So, how efficient are we really talking here? Well, the headline number is just staggering. You end up training only about 1%, and honestly, often even less, of the model's total parameters. This is a complete game changer. Your compute costs just plummet, training time shrinks from weeks down to a matter of hours, and all of a sudden, custom AI is something that's actually accessible to everyone.
All right, so theory is great, but what does this actually look like in a real-world scalable architecture? We're going to use a hypothetical company, let's call them Skystream Airlines, to see exactly how this strategy plays out in practice.
So here's the business problem for Skystream. They're global. A customer in the US, they expect a friendly, really casual chatbot. A customer in Germany, they're going to want a formal, precise, direct tone. And if you're interacting with a customer in Japan, you absolutely have to use high politeness honorifics. Now, the old way to solve this would mean training and hosting 3 separate, massive 70 billion parameter models. The cost would be just astronomical. But here is the PEFT solution in action. It's beautiful. You have a single, frozen base model hosted on one server. When a request comes in from New York, the inference engine dynamically loads this tiny little adapter US to give a friendly, casual response. A second later, a request from Berlin comes in. The engine instantly swaps out the US adapter and loads the adapter DE for that formal, precise answer. It's the exact same brain, just wearing a different personality.
And this technique, this ability to load and unload these tiny adapters on the fly based on, say, the user's location, that's what we call hot swapping. It's what gives a single AI instance the incredible power to wear all these different hats moment to moment.
I mean, the economics here are just transformative. Look at this. A full 70 billion parameter model is a 70 gigabyte file. It's huge. But a LoRa adapter, the thing that contains all that custom style and personality, it's only around 100 megabytes. That's literally the difference between moving a freight truck and sending an email. It makes storing them and swapping them incredibly fast and cheap.
Okay, let's bring this all home. What is the final business and architectural takeaway from this whole PEFT and LoRa strategy? What's the bottom line?
It's really this simple. Skystream gets the specialized performance, the unique behavior, and the distinct personality of 3 different custom-built AI models. But, and this is the key, they only pay the GPU hosting and operational costs for one single base model. This is how you do personalization at scale without bankrupting your company.
So we have totally optimized the AI's brain. It's got the right knowledge, it's got the right personality, and now, thanks to LoRa, it has the right style. But it's still just talking, right? It can talk about processing a customer's refund, but it can't actually do it. And that leads us to the next big question. What happens when we give this AI hands to actually act on the world? That's where we're going next.